All right. Today we're going to be talking about the order of operations. Now, what is the order of operations and why do we need it? Well, first off, a mathematical operation is going to be any of the binary operations that we're used to. Addition, subtraction, multiplication, division. Now, when I say a binary operation, it sounds kind of scary, but really all that means is that it has one true answer. It is either true or false, right? Now, things get tricky when we start combining a whole bunch of these operations. The idea here is that we have an agreed upon order for these operations in the mathematics community, and that is precisely a set of rules that tells us exactly which order to do first and how we can get ourselves through some nasty looking compositions of different operations. Now, you may have heard something in the past, a bit of a mnemonic device that was prolific in mathematics up until this point, even really till this day. People use Pemdas. Right? Please excuse my dear Aunt Sally. Well, if this works for you, that's fine. The idea behind PEMDAS is a little tricky because people forget some of the nuances here with multiplication and division, and then here with addition and subtraction. And then we got to find out what P and E stands for. Oh, man. Well, get this. Maybe I could rock your world a little bit right now. I'm going to say we'll just forget about PEMDAS entirely. I never really liked my Aunt Sally anyways. This is another little mnemonic device, something that will hopefully remind you the very special order of operations while you're seeing these more complicated composition of these operations. Now, I still think of this in my head to this day. I've been doing a lot of math for the last several years, and I still think back to myself, oh, which order was that again? Oh, okay, right. So now, what I want you to be able to do is take this tool and utilize it throughout all of these problems that you've been working on in your homework. Now, what I'm going to use is a word, G.E.M.S. Gems like the precious stone, or maybe something that was perfectly done, like, oh, that was a real gem. No, I'm just kidding. But this actually is a real gem for remembering the order of operations. Now, what does G.E.M.S have to do with the order of operations? Well, I'm going to let you know. The G, the E, the M, and the S stand for something. I'm going to let you know what they stand for, and that in that order, we will perform these operations. Now, first, G stands for grouping symbols. Now, we've seen grouping symbols many times before. The most commonly used ones are going to be parentheses, maybe the square brackets, the squiggly brackets, everyone's favorite, and as it turns out, a fraction bar from, like, say, a rational expression is also going to be a grouping symbol. Now, what's the difference between any of these? In this context, nothing. They're all the same thing. All they do is really group together certain numbers with their operations. And as it turns out, usually we wind up just using them in a certain order just to kind of help us organize a little bit. Now, E is going to stand for exponents. That's going to be when we have any kind of number to a power, like 2 or 3. M is going to stand for multiplication or division. And a very interesting thing about this multiplication or division is that it's whichever one comes first from left to right. Interesting. Finally, S stands for subtraction or addition. And interestingly enough, this also will occur left to right, just in the order that they appear. So if subtraction comes first, then you do the subtraction from left to right. Now what I'd like you to do is just pause this video real quick and jot this down, because these are the 4 steps, the only 4 steps you need to know in order to do any composition of all these crazy operations that we have. All right, now that we've taken our notes, we have G.E.M.S on our sheet, right? Grouping symbols, exponents, multiplication or division, subtraction or addition. I like that it has an S at the end. It kind of reminds you that, oh, well, if subtraction comes first, then I should do that from left to right, right? Well, now, why don't we take this tool that we have and try to put it to work? Let's try a nice one, maybe 2 or 3 operations on here, huh? Maybe we'll take 10 divided by 2 minus 3. Now this one looks pretty nice, right? We are going to say, let's do all of the grouping symbols first. No grouping symbols. All right, cool. Now let's do the exponents. There's no exponents in there either. That's great. Okay, now we're going to move on to anything with multiplication or division. I see division here, and I'm going to go from left to right. It's the only occurrence of multiplication or division, so I'll do that one. Here's 10 divided by 2 is 5. Now we're going to just continue our expression down here. Now I'm left with 5 minus 3. That's nice. Equals 2. That was the last step of our G.E.M.S. Why don't we strengthen our skills a little bit here, huh? Why don't we take something like all right, I see some grouping symbols in there. I see some exponents. I see some multiplication, some division. All right, let's try it out. I think that even though this looks considerably more difficult than the first problem that we tried, I think using this G.E.M.S technique, we're going to be able to get through it. Let's check it out. Grouping symbols. I see a nice group right here. Nice little group of numbers. So we're going to identify the grouping symbols and just take care of what's inside first. Do a smaller, easier problem within this larger problem. I like to do that with a lot of my math problems, is just kind of break them down into smaller, more manageable pieces and then kind of bring it all together at the end. Now, within this parentheses, I have 3 divided by 3 minus 2. So I'm going to say, are there any more grouping symbols within this grouping symbol? No. Are there any exponents within the group? No. Is there multiplication or division? Aha, here we go. So I'm going to move from left to right, 3 divided by 3. 3 divided by 3 is 1. And then I'm going to continue by writing the rest of the expression here. We're still going to work within this grouping symbol here. We haven't checked if there was any subtraction or addition. Aha, there is. 1 minus 2. 1 minus 2 is negative 1. I'm going to keep that squared plus 6 times 3. Now, something to kind of take note here is that all of these lines are equal to one another. So we like to use these equal signs to let us know that we could reverse this process and get from any step to any other step. Now, I'm going to use my G.E.M.S again. What do I do first here? Well, I see a grouping symbol is just grouping the negative 1 together. Okay, so there's no more operations to do inside here. So now I'm going to get to my exponents. Negative 1 squared. Well, exponents, remember, are really just telling you to repeat multiplication, iterative multiplication. You take whatever the number is inside here and multiply it by itself the number of times that we have as an exponent, right? So this actually just equals negative 1 times negative 1. So all I'm doing is rewriting what that statement is, just for us to kind of get those wheels rolling, recalling the properties of exponents that we're working on as well. Now, negative 1 times negative 1, that is going to be a negative times a negative is a positive, right? So that is equal to 1 plus 6 times 3. All right, it looks like we're almost there. We're breaking this down. What do we have left? We have 1 plus 6 times 3. We don't have any grouping symbols. We don't have any exponents. What about multiplication? There we go. So we're going to do 1 plus 6 times 3 is 18. Now we're left with 1 plus 18. I think we can handle that. Got 19 at the end there. Now, something interesting about the order of operations is that a lot of people wind up kind of wondering to themselves, well, why do I even need to know this? Why can't I just choose how I want to do it? Well, I guess the thing is that someone or some people did choose the order at some point. And we've all decided that this is the best way to do it. So what it comes down to is, I think a similar situation would be something like the rules of the road, right? We have lines, we have speed limits, we have sides of the road that we expect other people to ride on. Now, you see, in mathematics, we expect that everyone is doing the same order of operations. You could pretty easily see an issue with something that, well, a math problem where one person gets one answer and another person gets a different answer, and they both think they're correct. It turns out. Now, you may be wondering, how can I mess this up? All it is 4 steps. There's G.E.M.S. I mean, isn't there something I could do wrong that I might not be thinking of? And, well, usually there is, right? So I thought I might just kind of highlight a couple of things answering the question, how could I mess this up? Well, first off, grouping symbols. They don't always change the answer. Now, for example, the real numbers have properties that we like to take advantage of, like, say, the distributive property of multiplication over addition. Now, let's see. 10 times 5 plus 2. Well, we know that this is actually equal to 10 times 5 plus 2 is 7. There was my working within the grouping symbol first, and now multiplying. 10 times 7 is 70. But as it turns out, we could also distribute this 10 over to either one. So it turns out it's the same thing as saying 10 times 5 plus 10 times 2. Now, 10 times 5 is 50, plus 10 times 2 is 20, and 50 plus 20 is 70. Look at that. Well, I did the problem in 2 different ways, and I got the same answer. Well, sometimes there are multiple ways. You may have noticed in the previous problem, the real messy-looking one, we could have chosen any of those grouping symbols to work on first. Notice that G.E.M.S, grouping symbols, exponents, multiplication, division, subtraction, addition. It doesn't say anything about the order of which grouping symbol to do first, right? I did mention something about taking the biggest group down first. I just like to do that because it makes me feel a little bit more accomplished as I work through the problem. I get that big one out of the way, and then boom, I can move to the next one. But as it turns out, you can choose any group to work on first, and that's actually going to wind up giving you the same answer. Now, that's not necessarily answering the question, how could I mess this up? But you could be thinking to yourself as you're going, did I choose the right group? If I did this first step wrong, I'm going to get these next 10 steps wrong. So what's the problem, right? The thing is, you have to trust the math. That's one of the things that I tell myself all the time. If I'm sitting in an exam and I get an answer that I don't quite like, but I checked my answer, right? Maybe I could work it another way, work backwards and see if that answer, works in the initial situation. And sometimes you just have a kind of a funny feeling, and I'm just going to have to say to myself, you know what? I just got to trust the math here. I know that I did all of the order of operations correctly. And if you know that you did it correctly, you have to trust that the math works. Because with this set of rules, it will always work. That's the great thing about math. When you learn the rules, it works. Pretty great, right? Now check this out. I know that you're not allowed to use calculators in this class, okay? But I don't think there's anything wrong with using a calculator at home to maybe check your answer after you've worked on a problem, or maybe there's just some tricky calculations that you don't feel like doing in your head at the moment, but you could definitely do it by hand if you wanted to, right? Now, calculators have become increasingly useful, right? Computers are just very fancy calculators if you think of it that way. Now, the problem with computers is that you need to know how to speak to them in order for them to do what you want them to do, right? And the issue is that many calculators get it wrong. A lot of the time, if you take your fancy TI-84 yada yada calculator, you type in a complicated enough issue, you're going to have to put parentheses around every single piece of operation that's going on in there. And it's going to take you longer to plug it into the calculator just so that it understands the right problem, that you might as well have just done it by hand, right? So what I'm trying to tell you is that, yes, if you know how to use a calculator well and you want to use it to check your answers, that's fantastic. But if you get in some really complicated composition of binary operations, right? We're trying to do several operations all in one expression, and you try to type the whole thing into a calculator, most of the time it takes more work getting the calculator to understand you than it does just working through G.E.M.S. G.E.M.S. Now, there's one last comment I wanted to make about the order of operations. This is something that's not going to go away, right? This is a fundamental piece of mathematics. You need to be able to do this arithmetic, right? And the order of the operations is precisely the only way to do the arithmetic correctly. So, when you think about studying for the test, don't think about memorizing G.E.M.S. Oh, G.E.M.S, I got to remember. What does G stand for? No, really what I'd like to do is just have this as a tool in your tool belt that you can pull out at any time and say, oh, well, I'm looking at a problem where I need to add, multiply, divide, subtract several things in a certain expression or some kind of equation. You're just going to know to yourself, Maybe there was a bunch of work that already led up with all this new material, and then all of a sudden now we just have this expression. And all we have to do is some arithmetic, and then we'll be done, and we found the answer. Now, the problem there is you got to be able to do that arithmetic, right? And the thing is that I know you can do it. I know you can do it.